Dear students, welcome to mathematics online classes. In the last class, we have did integration by partial fractions. With that, two types of integration already got over. One is integration by substitution, and second one is integration by partial fractions. Now we will go with the third method of integration, that is integration by parts. So integration by parts we are going to do now. Integration by parts. Integration by parts, it is like a product rule actually. See, suppose I have differentiation of two functions, differentiation of product of two functions, u into v is there. How we differentiate it? We have studied in the differentiation chapter. Differentiation of u into v is u as it is differentiation of v with respect to x plus of now second function v as it is differentiation of first function u with respect to x. This is what we have studied in differentiations. Now here with this I will explain you what is integration by parts. Now here integrate on both sides with respect to x. Integrating on both sides with respect to x. What happens here? Integration of differentiation of u into v with respect to x into dx here. This dx is for differentiation and this dx is for integration. Right hand side integration of u into dv by dx into dx, integrating with respect to x. In the same way integration of v into du by dx into dx. Left hand side what happens, you see, differentiation of u into v and integration of u into v. Both differentiation and integration is happening only for the product u into v. So differentiation and integration get cancels out here. We can write here u into v is equal to, but right hand side is not the case. You see right hand side here differentiation is only for v and u into dv by dx integral. So we should not cancel dv by dx and we should not cancel integration and differentiation here. In the same way happens in second case also, but in left hand side differentiation of u into v and also integration of that, it get cancels. Right hand side you keep as it is. Integration of u into dv by dx integrating with respect to x plus of integration of v into du by dx integrating with respect to x. With this what I want to explain, I want to explain you what is integration of product of two functions. Suppose product of two functions like x into sin x is there, sin x into e raised to x is there. Suppose I have product of two functions, then how to integrate it, that one we are going to do. After this what we did? We did integration of single functions, product of two functions were not there. Here we are going to deal with the product of two functions, integration of product of two functions. Now let me take this to the left hand side and this to the right side, so that I will write here, I am taking this v into du by dx to the left side. This become uv minus integration of v into du by dx into dx is equal to integration of u into dv by dx with respect to x. Now I will interchange LHS and RHS. This become integration of u into dv by dx into dx, which is equal to uv minus integration of v into du by dx into dx. It is integration of product of two functions actually. Product of two functions, here I will consider u as the first function and dv by dx as the second function. So what I do, let us put u is equal to first function, that is f of x, and then dv by dx is equal to, I will put second function, that is z of x. That will be integration of product of two functions, f of x into z of x. Okay. Next, here du by dx is there. Du by dx is what? If you differentiate this function, differentiating the function with respect to x, this become du by dx. Du by dx is equal to, right hand side differentiation, I will write it as f dash of x, and dv by dx, let me integrate this, integrating with respect to x. Why I am integrating? Here v is there, that's why. Integrating with respect to x, integration of dv by dx with respect to x is equal to right hand side integration of z of x with respect to x. See here, differentiation of v and integration of that whole become v is equal to integration of z of x with respect to x. Okay. Now if I name this as equation 1, equation 1 implies left hand side, that integration u means I am putting it as first function, that is f of x. dv by dx means I am putting it as second function, z of x, into integrating with respect to x. This dx will be as it is, which is equal to u means first function f of x as it is, v means integration of z of x into dx, integration of z of x into dx, then this minus as it is, this integral I am writing as it is. What is v? V is, I have again integration of z of x with respect to x, and then du by dx is differentiation of the first function, that is f dash of x into dx. This dx will be as it is. This is the integration by parts technique. How to remember this I will tell you, and I will rewrite this. Integration of f of x into z of x means integration of product of two functions, which is equal to f of x into integration of z of x into dx minus of, I used to read it as big integral into this f dash of x I will write first, so that remembering will be easy. F dash of x into integration of z of x with respect to x, this whole integral is with respect to x. This dx is for the second function z of x, and this dx is for the whole function here. Okay, how to remember this? We should remember it as integration of f of x into g of x, means integration of product of two functions, integration of two functions, where f of x is taken as first function and z of x is taken as a second function. Means integration of first function into second function with respect to x is equal to first function as it is. See, f of x is there, f of x, first function as it is, into integration of second function, minus one big integral, differentiation of first function. Here I kept first function as it is, here I am differentiation of first function into integration of second function. This second integral is also with respect to x only. So here I remember it like, na ಇಲ್ಲಿ ಹೆಂಗೆ ನೆನಪಿಡ್ತೀನಿ ಅಂದರೆ integration of first function into second function with respect to x is equal to first function as it is, ಒಂದನೇ ಫಂಕ್ಷನ್ ಹಾಗೆ ಇಡೋದು, into integration of second function, ಒಂದನೇ ಫಂಕ್ಷನ್ ಹಾಗೆ ಇಡೋದು, ಎರಡನೇ ಫಂಕ್ಷನ್ನ ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡೋದು ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಎಕ್ಸ್, ಮೈನಸ್ ಆಫ್ ಒನ್ ಬಿಗ್ ಇಂಟಿಗ್ರಲ್ ಐ ರೈಟ್ ಇಂಟು ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಆಫ್ ಫಸ್ಟ್ ಫಂಕ್ಷನ್ multiplied with the integration of second function into dx. Whole integral means the second integral is with respect to x. This is how we should remember. I want you to remember this. Means integration of f of x into z of x with respect to x is equal to f of x into integration of z of x minus big integral differentiation of first function into integration of second function with respect to x. That is how you should remember here. Now let us go with the examples on integration by parts. This proof they will not ask, just if you remember the method, it is more than enough. Okay, let me take the example here. Example 17 I will take. Example 17 is, example 17 it is given, find integration of x into cos x into dx. Find the integration of x into cos x into dx. How will you integrate it? Very simple. Here already we know integration of f of x into z of x with respect to x is equal to f of x into integration of z of x with respect to x minus of big integral differentiation of first function into integration of second function with respect to x. This whole integral is also with respect to x. Here you say integration of x into cos x, it is integration of x into cos x in the sense f of x means first function x, g of x means it is the second function cos x. This one we need to integrate. What we do here? We do means we will follow this method, that is f of x, we will keep this f of x as it is, into integration of second function means integration of cos x with respect to x minus of big integral into differentiation of first function. What is differentiation of first function? Differentiation of x with respect to x. F dash means differentiation into integration of second function. What is that? Integration of cos x with respect to x. This is differentiation, this is integration, and this product will be another one integral into dx. Okay, x into, what is integration of cos x? It is sin x minus of this big integral we keep as it is, differentiation of x with respect to x is 1 into integration of cos x is sin x, whole integral this dx as it is. Okay, next x into sin x minus integration of 1 into sin x means sin x it is into dx. Now x into sin x minus of, now you see integration of sin x. What is integration of sin x? It is minus cos x, minus minus becomes plus cos x, integration completed, right, plus c. What is this? This is integration of x into cos x with respect to x. You see, here I have product of two functions. First function is x, algebraic function, and second function is a cos x with respect to x. Sir, suppose instead of taking the x into cos x, if I take cos x into x, what happens here? That one I will explain with another one example. That is very simple example. I will take that one instead of this. Now, instead of solving the 18th problem, let me go to 19 to explain one important concept. Very important concept in case of integration by parts. Example 19 is given as find this is 19, find integral of x into e raised to x into dx. Find integral of x into e raised to x into dx. It is given like that. Okay, now let me solve this. First, here I know that integration of f of x into z of x with respect to x is equal to first function as it is, integration of second function into dx minus of big integral differentiation of first function into integration of second function, second integral, whole integral is with respect to x. I know this. Now I will use here, that is integration of x into e raised to x into dx is equal to, here I am taking x as the first function, this e raised to x as the second function. Okay. F of x means x here, z of x means e raised to x here. Okay. First f of x as it is into integration of second function e raised to x minus of big integral differentiation of first function, differentiation of x with respect to x, and into integration of second function, different integral of e raised to x with respect to x. This whole integral is with respect to x. X into, what is integration of e raised to x? We know this is e raised to x minus of big integral, differentiation of x with respect to x is 1, into integration of e raised to x with respect to x is e raised to x into dx. Now here I have x into e raised to x minus integration of e raised to x into dx. X into e raised to x, integration of e raised to x is e raised to x plus c. What is common here? E raised to x is common. I can write here e raised to x into x minus 1 plus c. What is this? This is integration of x into e raised to x with respect to x. See, I took x as the first function and e raised to x as the second function. I did this one. I got this answer. Instead of taking the x as the first function and e raised to x as the second function, if I reverse it, means e raised to x will be the first function and x will be the second function for me. Then what happens? Let us see. Integration of e raised to x into x with respect to x I am solving now, where f of x is e raised to x and x is second function z of x. E raised to x as it is, integration of x with respect to x minus of big integral differentiation of first function e raised to x with respect to x into integration of second function x with respect to x. Whole integral is with respect to x. E raised to x as it is. What is integration of x with respect to x? That is x square by 2 minus of big integral differentiation of e raised to x is e raised to x into integration of x with respect to x is x square by 2 into dx. Okay. This is e raised to x into x square by 2. This 1 by 2 constant multiple I will write outside. 1 by 2 into integral of e raised to x into x square into dx. Next, second integral you observe, again it is in the form of product of two functions, where first function is e raised to x square is a second function. Then what to do? Again we need to go with the method of integration by parts. Okay. E raised to x into x square by 2 minus 1 by 2 into, I will write this inside the bracket, first function as it is, integration of second function with respect to x minus of big integral differentiation of first function e raised to x with respect to x into integration of second function with respect to x. Whole integral is with respect to x, bracket complete. This is e raised to x into x square by 2 minus 1 by 2 into e raised to x as it is. What is integration of x square? That is x cube by 3 minus integration of e raised to x is e raised to x, integration of x square is x cube by 3, whole integral is with respect to x. What is happening here? You see, again we are getting here integration of product of two functions. E raised to x is first function, x cube is second function, 1 by 3 I will take outside. This become product of two functions. If you integrate again, what happens? You will get e raised to x into x raised to 4 by 4, then 1 by 4 you will take out, and the next step you will get e raised to x into x raised to 5 by 5. This outside constant multiples will be there. Now it goes infinitely, there is no end for that. So while choosing the first function and the second function, which should be the first and which should be the second, we follow one technique here. We follow one method, that is how to choose first function and second function. That is very important. That is very important in case of integration by parts. No need to take this. This is just for the explanation why that concept is required. First way I solved, first way I solved, that is enough. Okay. Now we follow the method known as isolate here. What does this isolate mean? We should choose the functions in this order only. We should choose the functions in this order only. Where you see product of two functions in the sense x is algebraic function and e raised to x is exponential functions. Here isolate, just these are the first names of 5 types of functions, where I means it is inverse trigonometric functions, L means logarithmic functions, A means algebraic functions, T means trigonometric functions, E means exponential functions. You should choose in this order only. Suppose one inverse trigonometric function and one logarithmic function is given, then inverse trigonometric function should be the first function, logarithmic should be the second function. Suppose one inverse trigonometry and algebraic function is given, which one will be the first? Inverse will be the first, algebraic will be the next function. Suppose one algebraic function and one trigonometric function is given, which one you will choose first? Algebraic will be the first, trigonometric will be the next. Suppose one inverse trigonometry and one exponential function is given, which one to choose first? Inverse trigonometry should be first, exponential should be the second. Like that we need to choose the functions. Okay, let me write. E means this is exponential functions. Exponential function. Exponential functions means the functions like e raised to x, all those, e raised to x, e raised to 2x, e raised to 3x, like that, whatever it can be, those are exponential functions. Next, T means what? T means it is trigonometric functions. Trigonometric functions. What are the trigonometric functions we know? 6 trigonometric functions we know. Those are sin x, cos x, tan x, then cosecant x, cot x, all those. And suppose it is sin 3x, sin 4x, like that, if it is given, all those comes under trigonometric functions only. Then what about the algebraic functions? Algebraic functions means A means it is algebraic functions. Algebraic functions means functions of the type like x, x square, x cube, x by 2, x 3 by 2, like that. Those are algebraic functions. Next, L means these are logarithmic functions. Logarithmic functions. Constant functions, suppose it is given 1, 2, 3, 4, constant functions also comes under algebraic functions only. Now logarithmic functions means functions of the type log x square, log x cube, like these functions are comes under logarithmic functions. Now coming to this first one, this is I means inverse trigonometric functions. These are inverse trigonometric functions. Inverse trigonometric functions means we have studied sin inverse of x, cos inverse of x, tan inverse of x, cosecant inverse of x, like that. Suppose it is given sin inverse of 2x by 2, like that, whatever it is given, inverse is there means that comes under inverse trigonometric functions only. Once again I am telling you, while solving the integration by parts problems, we should remember the isolate rule. Isolate rule. It says how to choose the functions in order, which should be the first function and which should be the second function. That should be done according to the rule known as isolate, where I means inverse trigonometric functions, L means logarithmic functions, A means algebraic functions, T means trigonometric functions, E means exponential functions. Like this we should proceed. First, second, third, fourth, fifth, like that. In case of while solving x into e raised to x into dx, two ways I did. Here is first one, here is second one. X into e raised to x means this is algebraic function, this is exponential function. Okay, first case I took x into e raised to x, so I took it in the particular order, so we got the answer very easily. There was a end. In second case what I did, I took it in reverse, means exponential function first I took and algebraic function second I took. There reverse happened. That means that it was going like that. This is the rule we follow. Fine. Now I will go to the example 18. Example 18 says, find integration of log x with respect to x. Example 18, integration of log x with respect to x. How will you do this one? We know the differentiation of log x. Differentiation of log x is 1 by x and integration of 1 by x is log x. But have we did integration of log x? No. Integration of log x we didn't do. Now we are going to do that one. Integration of log x. See, integration of log x is there, we will solve this by integration by parts. Sir, here only one function is there. Yes, only one function is there, but we will take it like integration of log x into 1. Integration of log x into 1 with respect to x. Here you see two functions are there. First one is according to the islet you see. First function I am taking log x, L log x, then followed by algebraic functions. One is algebraic function, okay. Log x will be the first function, 1 will be the second function. Now we will solve the integration of log x. See, again product of two functions, I will write that formula. We know integration of f of x into z of x, where f of x is taken as first function, z of x is taken as second function, which is equal to f of x into integration of z of x with respect to x minus of big integral differentiation of first function into integration of second function with respect to x. Whole integral is also with respect to x. Okay, here integration of log x into 1 with respect to x is equal to, first we will keep this f of x means log x here, z of x means 1, f of x as it is. Next integration of 1 with respect to x minus of big integral f dash of x means differentiation of first function log x with respect to x into integration of z of x means integration of 1 with respect to x. What happens, you see, log x into integration of 1 with respect to x is x minus big integral as it is, differentiation of log x is 1 by x into integration of 1 with respect to x is x, differentiation over this integration over, I used to call it as small integral, this is big integral, there is no difference, into dx. Here you see x get cancelled. I have x into log x minus integration of 1 with respect to x into log x as it is minus of integration of 1 with respect to x is x, integration completed, right, plus c. So this is what? This is integration of log x with respect to x. I can write one more step here. Integration of log x with respect to x is equal to, x is common here, x into log x minus 1 plus c. This is what the integration of log x is. Very simple. Just we need to remember the rule highlight. Then we proceed with integration by parts. Thank you. Remaining problems we will solve in the next class.